to take a look here at lesson 8. We're going to look at using formulas in geometry. Now, the formulas that we are going to be taking a look at today, you should have already seen. Nothing here should be new. Perimeter. Again, when we take a look at the perimeter, all it is just the distance around an object. So if I'm looking at a rectangle, well, that would simply be, 2 times the length, 2 times the width, because length and width are the same, aren't they? Okay. Now, what would be a good representation of perimeter? If you had to give me an example that would be used in real life. Fence would be the perfect example of what perimeter would be. You've got a fencing up around and you're keeping things in, keeping things out. You'd need to know the distance of that. So, perimeter here is just simply 2 lengths, 2 widths, add them up. Not a problem. Area. Now, you have seen the area formulas before. Make sure your Chromebooks are closed and you're paying attention to me. So, area. Again, nothing new. You have seen this before. Now, we're talking about the area being stuff inside of it. Okay? So, you got a perimeter up, which fence up. The area inside versus what's outside, right? So, we're always looking at what's inside of it. Now, area, length times width. Area will always be in square units. I mean, if you look at the ceiling is comprised of a whole bunch of squares put together, right? It's area. So, length times width for the rectangle, area of the triangle, base times height, half of it. You may also see it written down like this, where it would be base multiplied by height divided by 2, okay? And so that was what area would be equal to. Is it any different? No, it's just a different way of working it. Now, one of the things I will tell you right now is this always must be there between the base and the height. If you don't have a right angle going between it, you've got problems. That is the only way to identify this. Now, we got one more formula here. You've heard of this guy, heard of this before, haven't you? A squared plus b squared is equal to c squared. Good, I'm glad some heads are going. Pythagorean theorem, good old Pythagoras. Pythagoras. Up here. Philosopher, mathematician, by the way, that was 580 to 500 BC. So not only is it 2016 years ago, plus another 500. Been away a while ago, right? But anyways, young man, he traveled in Egypt, saw the elementary principles of geometry used in building the pyramids and surveying. He would later develop these mathematic principles. Now, when Pythagoras began teaching, he and his more advanced students formed a close-knit group known as the Pythagorean Brotherhood. The Pythagoreans were bounded by oath not to reveal the teachings or secrets of the school. So because of that, it's difficult to separate the discoveries of Pythagoras himself and those of his students. He is generally credited with the discovery of the Pythagorean theorem, which can be used to find the length of one side of a right triangle when the other two are known. The Pythagoreans considered numbers to be the guiding principle of their philosophical system. They found a close connection between numbers and the order, proportion, and harmony of the universe. Their studies laid the foundation for all later developments in geometry. So if you want to blame somebody for geometry, that's it. But in order to have the things that we need, you got to have geometry. When they would look around and they would see how things were in their world, they seen that they could represent things by numbers. And you'll see a little bit more about that next week. For right now, the Pythagorean theorem always is in this format, A and B. A and B are always going to be the legs, right angle down here. C is always going to be the length of the other side. That is just the way it always is. So, let's try this. If I want to find the perimeter of that triangle, what do I got to do? Perimeter. Go around. Go around. I want to put a fence up like this. Oh, now you say add. Okay. So that's going to be 8 plus 8 plus 8. So we end up with 24 inches. Just add up the sides. So, perimeter of the rectangle. Well, I only know 12 and 8. Double, because 12 up here is the same as down there, right? So that would be 24. If this is 8, does that side have to be 8? So plus 8, so that would be what? 16. So now I get a grand total of what? Just 40 inches. Okay. Regular pentagon has side length of 8 inches. What's its perimeter? Why? 5 times 8, because there's 5 sides. So it would just be 5 multiplied by 8, so we end up with 40 inches. It's not all that difficult. As long as you know the formulas. The formulas are the rules. And the rules are what make life easy, right? Therefore, math is easy. As long as you know the rules, you can play the game. So, let's try this. Area. How do I deal with area? Multiply them. So, what would I have to multiply here in order to find the area of that? Okay, so you want me to take 14 multiplied by 3, and that would give me what? 42 cm squared. Always squared. Now, what about B? Oh, I just multiply 108 and 9, right? See, now we've got a bit of a problem. Because we were just given the length and the width up here, we could multiply them together. But when we've got something that looks like this, we write out the formula. Area is equal to length multiplied by the width. Okay? What is the area here? 108, so I'm going to put the 108 with the A, right? So that would be 108. Do I know what its length is? No, so I just got the L multiplied by W. What's its W? Well, it'd be 9. So what do I have to do to solve this? Divide by 9, divide by 9. And so that means, what's 108 divided by 9? 12. So 12 is equal to L. That's all it is. But sometimes you are going to have to do that. Put the formula down, put the numbers in, and solve for what's left. See, up here it's pretty easy if the area, we don't know what the area is, but we're just dealing with 14 times 3. We know we got to multiply. So be careful about this. Now, fun stuff. Pythagorean theorem. I want to find the length of the hypotenuse. Now, when you're first starting off with this, I would recommend drawing things out and identifying which is A and which is B and which is C. So what could A, or where could I put A? 5, 12, or the other side? 12. Okay, so I'm going to put A here. What's B? Which one should I put B on now? 5. I'm going to put that down here. So that means C has to be here, correct? Okay. So that means it's going to be A squared plus B squared is equal to c squared. Okay. Now, if you learn to write these things out, the rest is really super simple. What's a? 12. So that means it's going to be 12 squared, right? What's b? So that's going to be 5 squared is going to be equal to c squared. Well, what's 12 squared? 44. 5 squared, it's equal to c squared, right? What's 144 plus 25 added up to? 169 is equal to c squared. The problem is I want to know what c is equal to. So what do I have to do? You know, I took 12 and I squared it and I got 144. How do I get back to 12? I was at 25. How do I get to 5? Square root. So what's the square root of 169? So that's 5, that's 12. This side is 13. Not bad, huh? Yes, ma'am. There are some things that you should know. What is 2 squared? What's 3 squared? Remember, squared is times, right? 3 times 3, so 3 times 3 is 9. What's 4 squared? 5 squared? What's 5 times 5? 6 times 6. 36. 7 times 7. 49. 8 times 8. 64. Now, what happens if they aren't those nice numbers? Well, I suppose we have these wonderful new inventions called calculators. So, I could go through and just simply do this. I could I could hit my square root key and go 169, enter, 13. So that's generally the best thing that I'm going to be able to do. So, I mean, that's really all that you got to worry about. Okay? If you don't know how to deal with it, you just grab the calculator and you go from there. But you should know your perfect squares pretty much up through 16 comes up quite a bit. Usually, you know, a lot of them are easy because if you've done your 12 by 12 time table, you got it up through 144. But I will tell you this, numbers like 169 come up quite a bit. So just be aware. So now I've got another problem. Find the area of that triangle. Area of the triangle is base times height, right? Divided by 2. So that means I take 5 times 3 divided by 2, correct? No. Remember, if you're going to do the area on a triangle, the right angle down there is between the base and the height. So, do I have all the information that I need? And no, I don't. So we got to do some work in order to figure that out. So, first offhand, I got to find out what this is going to be down here, correct? So we're going to start off again here with a squared plus b squared is equal to c squared. So if b is there, what's a? 3. 3 squared equal to 5 squared. Okay. So what's 3 squared? 9 plus b squared is equal to, subtract 9, b squared is equal to what? 16. So b is equal to 4. So I know that's 4. And by the way, here's a little trick. You ever see a right triangle? the hypotenuse is 5 and one of the sides is 3 or the other side is 4, it's always 3, 4, 5. Always. So, do I have enough information now to figure out what the area of this triangle is? Yes, I do. So all I got to do is take base, which is 4, multiply it by the height, which is 3, and divide it by what? Base times height divided by 2. So let's see, 2 goes into 4, and I get 2. 2 times 3 is 6, so that means that the area is going to be equal to 6 feet squared. Again, nothing here is really new. You've played with these things before. You've seen all these things before. So, what I want you to do is I'm going to give you 2 minutes, and I want you to do A, B, and C. 2 minutes to do A, B, and C. All right. Here we go. Let's see. Missed all. So I got a question for you on A here first. If I got a question like this, would it be a good idea to go through and draw out the triangle to begin with? So I could have something that just looks like that. Does it have to be perfect? No. So how long are the sides on this thing? 6.5, right? So does that mean each one is 6.5? Oh, they're different? The perimeter of a triangle with congruent side lengths. So that means 6.5 here, 6.5 here, and 6.5 there, correct? So what would that add up to then? But isn't that the perimeter then? Okay, so there you go. 19.5. So I get 19.5. So if you need to draw yourself out the picture, put in the numbers so that you can see what you got to do. So let's do this. Parker. Nope, not Parker. Ty, sorry. So Ty, what's the perimeter of the rectangle? 536 centimeters, right? I said 536. I learn how to write, that always helps. So we get 536 centimeters. Well, let's think about this for a second just to double check. If this side is 1, 2, 3, that side's 1, 2, 3, so we can double it, right? And that would be 246. It's two of those. 145 here, 145 up there. If I add two of those together, I get 290. 6, 3, 1, 536. So, again, now could have I just taken 123 plus 123 plus 145 plus 145? Would have got me the same thing. Yeah. For that matter, I could have taken 123 plus 145, added those up, multiplied it by 2. The answer again. There's usually more than one way to do this stuff. It's just, you know, what's easier for you at times. What do you see? So, let's see. We already picked on her, so we're going to go to Isaac. What did you get for C? Nope. Sorry, sir. It's a six-sided figure, so how many sides are on a six-sided figure? Okay, and if each side is 16 inches, what do I do with 16 and 6? Yep. So you get 16 times 6, not 16 to the 6th power. So 16 times 6 is what? 96, and we're still talking perimeter, so this is going to be inches. Okay? So, give this a try. Give you a minute and a half. Play with this one. Yep, do D and E. D and E. What? That's bring it up here. That's the way. So basically saying you make a better door than a wood. Okay. So, let's see. Tara, what'd you get for D? 307.4 feet squared. I can take that, can't I? Because all she did is just multiply 21.2 times 14.5, right? And there you go. Okay, well, worst case scenario, we can always grab a calculator and go back and check. Turn that back on. Clear that out. 21.2 times 14.5. Yep, there we go. So, Next one. Fine. Logan. So, what do we get here? What? I can't hear you. Still working on it. Well, we. Okay. So, I've got the base of a rectangle, right? So I know that it's going to be something that looks like that, right? So, it says the length is 6 centimeters, so I could put 6 here, right? So what I'm really worried about is what goes over here, right? Because I know the area is 12. So we're going to set up the formula. Because it's going to be area is equal to length multiplied by the width. So 12 is going to be equal to 6 times the width. Divide by 6, divide by 6. So it looks like 2 is equal to the width. Does that make sense? When in doubt, draw it out. Yeah. When in doubt, draw it out. Helps every single time. So, I'm going to give you 2 minutes and I want you to do these two problems. What's a hippopotamus? A hippopotamus is a very, very big animal. Okay? Yeah, hippopotamus. It's big, right? So what's big here? Yeah, hippopotamus. Yeah, because it's the bigger side, the hypotenuse. I always think hippopotamus because it's the bigger one, right? Hip, you catching on now? Ah, see, there is a method to my madness. So here we go. Let's see if we can't. Let's see, 5. We already. It really likes picking on you today, doesn't it? So, okay, Chris. What's B? B, you say, is 6. Okay, let's check. Now, first offhand, it seems to be missing something, doesn't it? Well, besides that, it doesn't really identify where the right triangle is going to be at, correct? Now, but if we're supposed to use the Pythagorean theorem for this, can we go then and you make the assumption that the right angle is going to be right here? And the answer would be yes. So we're going to start off with a squared plus b squared is equal to c squared. So that gives us, in this case, 8 squared plus b squared is equal to 10 squared. 64 b squared is equal to 100. Subtract 64, subtract 64, and I get b squared is going to be equal to 36. So b is equal to 6. Okay. So, let's give this a whirl. Last one here. That's right. Yeah. So Parker, what do you think the area here is? Do you have an answer written down? Okay. Now, first offhand here, did you write down the triangle for this? Draw it out. Yeah, when in doubt, draw it out. So, I got a right triangle. Okay. It says hypotenuse is 17 millimeters, so that means the 17 is going to be over here, right? And it says one of the lengths is 15. I'll put 15 over here. Does it matter which one it is? No. So that means that I've got a squared plus b squared is equal to c squared. A, I can call it as 15 squared, plus b squared is equal to 17 squared. Now is when the calculator comes in awfully darn handy. What is 15 squared? 225. Plus b squared is equal to 17 squared, which is what? 289. If I subtract 225 to both sides,
The answer for today's trivia question. The question was, which staff member once gave an entire spoonful of wasabi paste to Daniel's guacamole? It was Miss Miller. The winner of this is Faith Vertikowski. HBC, Mrs. that brought in the library for your prize.
what number do we get?
It's falling through, so please come to the office.
64.
Tina Nelson, Isaac Johnson.
So, if b squared is equal to 64, b is going to be equal to what? 8. And there you go. All right. Yeah, because we're supposed to find the what? Area. So that means it's going to be 8 times 15 divided by 2. That cancels out. I get 4, and I end up with 60 millimeters squared.